Okay, sampling error. You know what? I should also add the word sampling variability. So sampling error and sampling variability, and this is page 16 of the notes spiral. So recall that we define statistics as a study of how to collect, organize, display, describe, analyze the data from the sample in order to make generalizations about the population parameter of interest. So basically we had the 4 units, and then we're going to, and part of that was to make sure that we can make claims or generalizations about the population as a whole. And we did that because it was reasonable to take a sample, but unreasonable to take a census. That is the purpose of statistics. Don't forget that the parameter is a numerical measurement of the population, which could be the mean, the median, the variance, et cetera, a long list of things. From the sample or subset of the population, we find estimates of the population parameters. The estimate of the population parameter that comes from the sample is known as the statistic. Once again, remember, samples have statistics, populations have parameters. Please don't confuse those. All right, so we talk about the sample mean or sample median being estimates or approximations for the corresponding population parameters. For instance, back to if I wanted to know the true number of hours that Reagan students sleep on average per week, I could find an estimate by taking a sample of 50 Reagan students. If I took a good sample, one that represents the population of Reagan, my findings should be pretty close to the actual number of hours that are slept. However, the value I calculated from my sample is likely to differ somewhat from the actual number. Okay, the difference between my sample statistic and the population is known as sampling error or sampling variation. Notice that word variation because that's going to help you with a multiple choice problem. All right. And more specifically, I can help reduce that error or that variation by increasing the sample size. So as the sample size goes up, the variation goes down, or sampling error goes down. Remember, sampling error is not bias. Bias cannot be fixed. We can't eliminate sampling error, but we can minimize it by increasing our sample size. All right? So sampling error or sampling variation or variation is due to random chance, and we can describe it by a probability model, and we can minimize it by increasing the size of the sample. Sampling error is a recognition that every random sample selected from a population is likely to be different. If you go out and do a random sample of 100 students at Reagan, do you think your survey is going to be exactly the same as someone else's? And the answer is they'll be close, but not likely to be the same because you're not likely to talk to exactly the same people. So because there are so many variables or factors within a population, it's nearly impossible to design studies that account for every variable without doing a census, which we said is difficult, if not impossible. Because we cannot account for all of the variables, we involve chance in the selection of our sample to equalize the effects of variables that we cannot be accounted for. This is huge. Because we cannot account for all of the variables, we use chance or random selection to equalize the effects or to balance out the effects. Even with a well-designed study or experiment, the sample statistic is only an estimate of the population parameter. And the difference is known as the sampling error, all right? And there will be error. It's not that anything's wrong, we accept it. We recognize that it's not perfect, but it's going to be close enough if we carry it out correctly. And we can minimize that error by increasing the sample size. Increasing sample size doesn't help with bias, right? Increasing sample size doesn't help with bias. Recall that when we ran our simulations, there were multiple approaches that were all considered acceptable and led to different responses. So you all may have run it differently than me and still receive full credit. All all right? Which means we all had different answer. However, if we had increased the sample size, the amount of variation in our responses would have decreased. It makes sense that if we increase our sample size, that our result would be closer to the true population parameter, because if we get closer and closer to actually conducting a census, we should be getting closer to, or surveying everyone, we should be getting closer to the population parameter. So we can say that as we increase our sample size, that the difference between the population parameter and the sample statistic will be less. And that leads us to say that the amount of variation diminishes as our sample size increases. And again, that's going to show up over and over again on that multiple choice assignment. Obviously, our observations may be more varied as the sample size increases, but on average, the sample statistics will vary less, all right? And they will vary less as a percentage. So the amount of variation diminishes as our sample size increases. And once again, please do not confuse sampling error with bias. Sampling error is a term used to describe properly collected data. In other words, you did it correctly. You ran your simulation correctly, but it didn't actually match the population. In other words, given a proper method of data collection was employed, I would expect that my sample will vary or differ from the population. Error is normal and is predictable, and therefore we can control it. We cannot eliminate it, but we can control it by minimizing the sample, by increasing the sample size. So we can minimize the effect of the error by increasing the sample. And then once again, unlike sampling error, bias is a problem in the design or in the method. So bias is a problem in the design or in the method of collecting data. And increasing sample size will not fix biased data. All right. Biased data cannot be fixed and must be discarded. So once again, sampling error versus sampling bias. Bias is a bad design or poorly executed, and it's going to overrepresent part of the population. We cannot fix it. Increasing sample size will not help. Sampling error just means that everybody's sample is going to be a little bit different. You got 33%, I got 35%. We can minimize it, sampling error, but we cannot eliminate it. And we minimize it by increasing sample size. Thank you.